So moving towards our next session. Every time a vehicle moves, accelerates, or take a turn, the tire silently performs an extraordinary engineering task. It carries load, absorbs shocks, maintains grip, and ensures safety all at once. But how do engineers design such a complex structure and ensure it performs reliably under countless conditions? Today's session, Tyre Design and Validation by FEA, will take us into that fascinating world. And this session will be presented by Mr. Bhaskar Halder. He is a professional with over 20 years of experience in new product development, tire technology, and industrialization. He holds a BTech in mechanical engineering and MTech in materials engineering and a postgraduate diploma in robot technology. Currently, he is designing products for PCR and OHT tires at Birla Tyres. Previously, he served as head of the product development at Mahansaria Tires, leading the design of ROTR and radial OHT tires, and as a team lead at JK Tires, focusing on the TBR tires. With extensive experience at Birla Tyres, he has been instrumental in designing a wide range of tires, including TBR, PCR, and high performance variants. We are feeling privileged to get such an eminent personality as our resource person in this session. Sir?
There is some network issue. Just wait a minute, he will join.
Okay, sir. So I'd like to tell that the participants should submit the feedback form for every sessions.
Bhaskar already have joined.
Yes, yes, yes. Sir, you can start your presentation.
Hello.
Yes, sir.
Yeah, sorry for that. I am in a hotel and try to connect through hotel network. Sorry for that actually. Okay. So shall I start?
Yes, sir. Sure, sir.
My screen is visible, please.
Yes, sir. Your screen is visible and your audio is clear.
Yeah. Okay. Thank you. So thank you very much for all of you for giving me the opportunity. So myself, Bhaskar Halder, I am working in Birla Tyres and R&D department. So today my the point of discussion is that how actually the FEA actually beneficial for our tire designing. Okay. So in that, I will cover the below points that what is the understanding of the basic tire structure and design, why tire is very special, and how actually we are designing our tires. So I'll try to give you some uh, flow chart that how we are actually from start to end point. Previously, what happened actually, it is actually main designer that this property can be good or bad, good with this some specific
వీడు అప్పుడప్పుడు ఊరికి వెళ్ళిపోతున్నాడు అన్నట్టు అట్లా
Sir, you are mute. Please unmute yourself. Bhaskar sir, please unmute yourself.
Hello.
Yes, sir.
Now
Yes,
I'm
sir. Yes, sir.
audible? Hello.
Yes, sir.
Please full screen.
Hello.
Yes, sir. Your audio is clear, sir. Just make the PPT in full screen, presentation in full screen
I'm
mode.
not audible actually. Your voice is not coming to me.
Hello, sir.
Please full
Sir, you are
screen.
audible, sir.
Sir, there may have been some internet issue or bandwidth issue over there. That is why the sound we are getting actually it is stuck in between.
Hello.
Yes, sir. Are you?
Yeah, now I think it is okay.
Okay, sir. Okay, sir. Just
Okay.
make the presentation in full screen mode, sir.
Okay. Just a minute. Now it's
Yes, sir.
okay.
It is fine. Yes, sir.
Okay.
Yes, sir.
Sorry. So, so previously, what we are actually doing, the designer actually designing the tires that is based on their previous experience and their judgment, and their judgment actually. So nowadays, what actually we are introducing the FEA simulation in our design stages, and with that we are actually can correlate whatever the validation part actually we can done through the FEA simulations. Then what is the FEA workflow that is actually follow in our tire designing, and some examples of tire performance simulation. I will show you some performance example of tire simulation and how we are actually validating the simulation results. Now if I go to the if so to make this presentation a little bit interesting, just I'm giving some historical incident that how the tires actually developed. So if you see in 1845, 1888, that is the first pneumatic tires actually, a bicycle tire that is developed by Dunlop. That tires developed by the Dunlop. After 1900, the tires little bit change and it called as a bias tires. 1946, there is some another advancement of technology happened. It is called the radial tires. And in case of 1970, we again another advancement happened. That is called the steel belted radial tires. In 2000, the requirement has changed. Now the requirement is for the low rolling resistance, because fuels are expensive and everybody is working on for the fuel saving and all. So for that reason, the lower rolling resistance tires requirement has absorbed in the year of 2000. And 2022, now everybody knows that now it is a days of EV tires. So everybody actually working on EV tires. So it's a next generation tire developments happening for the EV vehicles as well. So if I see that 1845, 88, then early 90s, there is a bias ply automobile tires that is developed. One interesting thing actually I want to share you that that the era of 1880s, the fast petrol cars actually developed. So that time what happened, that time fast pneumatic tires also developed in that same parallel time. 90s, the now the cars actually it gone for the mass production. So again the advancement happened as a terms of bias ply. 1946, then the highways are made, and we need the car with the faster running. So that time radial tire technology evolved. 1980s, that is the uh, another improvement happened in the for the car development. In, if you say, there is a lot of safety electronics part actually added into the cars. So that time we need tubeless tires. So that is the development of new development that is called the tubeless tires. And 2020 then EV has came, so the requirement has changed again. There is to lower error or lower RR, that is the rolling resistance and the smart tires. So there is the interesting thing is that the tires, whenever it is developed, actually it driven by the car development actually. So whenever the car development and car advancement happening, so that time tire also developed to match the property of the car as well. So if you see the evolution of tire technology ladder, so first there was some wooden locks, that is the some circular thing was there, then wheels of circular objects, then there is solid tires developed, then pneumatic bias tires, then tubeless radial tires, and along that. So it's, if you see, the journey has come from 1845 to now 2026. So this journey is still beginning. New requirement actually is coming for the tire manufacturers as well. So actually, if I say that what is tire actually, so if I say that tire, if I go for the definition, the tire is actually a toroidal shape. So what is toroidal? Toroidal is actually a torus shape. So it is actually a ring-like structure like tubes, and its property is anisotropic. Why it is anisotropic? Because if I see the rubber is tire is look like a black and round shape, but if you check the cut section, then there are a lot of components are there. The upper part of the component we call as a tread, that is actually touching with the ground. It is made of rubbers, and below the tread there are some steel belts are there. So and there are some plies are there to from bead to bead, there is some plies are there. So if you see in case of tires, there is rubber, there is steel, there is nylon or polyester fabrics are there used in the tire. So if you see, it is a composite, and the rubber having a different property. It is actually hyperelastic property and for the steel it is a purely steelastic property, and for the for the ply, that is nylon and polyester, the property is in between of the both. So it is very difficult to, while it is as it is a composite, so it is very difficult to design a tires with such type of different of stiffness, different of elastic property of the material. And tire is a non-linear material actually. So because the material, because in tires there is a material linearity, steel is a elastic, rubber is a hyperelastic. So always tire is a non-linear material, and it is a flexible items because it has to have some shock absorbing capacity. So when we actually load the tire, so it flex. So this flexing actually give us the comfort. So the tire is a flexible membrane. It's a composite membrane and capable of containing air, because who actually, in case of tires, who actually takes the load, the inside the air is actually that airs maybe for the nitrogen and maybe for the natural air that is available in the atmosphere, that is also can be take as a containing fluid. So what is the function? The tire function is actually, it's a load carrying. It should have a load carrying, because while designing of any tires, it should be fitted in the vehicle. So actually what happened for the while we working with the OEMs, so OEMs giving us that what type of load that vehicle will carry. Suppose in case of trucks, in case of passenger car tires, the requirement of the load is different. So accordingly, we are designing the tire based on the load carrying. Another point is that the traction and braking is the another point. Why it is need traction? Because if I give an example of shoe having the if you see that there is some patterns are given to the shoes. Why? Because to give the traction. Because in case of sometimes what happen actually, when the shoe is wear out, then actually there is a when it is in a wet condition, what happened actually, we sleep. We sleep. For that reason traction is required. So for that reason we have to give some pattern to the tires. What is the braking? Braking is that suppose if we need to stop my car, then I have to apply the brake, and whatever the best stoppage distance is required, that depends on the tire designing at all. Then another thing is coming, there is the ride and comfort. So when actually we are driving our cars, we need some shock absorbing, because whenever the tires is going to the running to the paves or any roads, so always there is a shocks are coming, because we know as an Indian there is a lot of potholes are there in Indian roads, so that we need some comfort, so that shock should not be transferred to the passenger. So there should be some ride and comfort as a property of the tires. It should be durable and safety, because if you see, that tire is a safety item actually, because one of a sudden if the tire fails, then there may be some loss of human beings lives, maybe in a danger conditions. For that reason, tire is a very safety. So while we are designing the tires, our main motto is to make the tire as a safety equipment, and as a factor of safety, we call as a factor of safety. So we always keep more than 8. So as tires are very much as a safety device, if you say, so we are keeping the more safety to the tires. There is the next is the wear resistance and the durability. What is that? Because the tire should have to have some life. Like if I have some, if we have car, then if you say that car having the mileage of around say 80,000 kilometer to 1 lakh kilometer, this is the general average mileage of any tires. So the compound, so my compound should be like that it can be wear resistance and give this much of mileage to the customers. Noise and vibration, that is also important, because tires actually, while it is in a running condition, it actually generates the noise. So and as per the radial force variation, there is, when it is actually in running condition, there are some radial force variation happening into the tires. So vibration is also coming from the tire to our steering and to our human body. So for noise and vibration, nowadays this is a very much improvement area actually walking by the tire industries. One is the noise and another is the vibration. So for this these are the basic function of a tire, and as a designer we have to meet this function so that customers can happily run the tires. So if I go for the basic, that this is a one cut section of a tires. So if you see that this tires is mounted on a rim, and the just a minute, so so this is the trade area. This is actually touching to the ground only, and it is made of, it is called rubber, but it is rubber. Again, there are a lot of materials are there in this trade portion, because it is the raw materials of a tire is mainly for like natural rubber, synthetic rubber. Then as a reinforcement material, the carbon is carbon and silica are using for the reinforcement element. The sulfur is being used to, it is creating a cross linking between the rubber and the feelers. And there are some accelerators, then retarders. Whether tire suppose there are when a tire is a prolonged use in the atmosphere, there is a chance of oxidation, and the chance of ozone attacks are there. So there are some chemicals are we are giving to protect the ozone cracking and the oxidation. So tire, the top portion of it is actually touching to the ground. It is called the tread, and it should have the traction property. It should have the wear resistance property. It should have the lower rolling resistance property. So that while designing the tires, they have to keep this point as per the tire applications. Below the tread, there are two belts I am showing. There is the first belt and the second belt. So it is made of steels. it has some specific angle, say it is maybe 24-25 degree angles are there, and these two belts are one belt is bigger width, another belt is the smaller width. And if you see, there are some plies, are going, that is called the body ply, we call it as a body ply. It is made of polyester or nylon, okay. And there is some inner liner. So this is the inner liner. Actually, if it is a tube type tire, then the material of the inner liner is different, because it have to retain it should not pass the air from inside the air actually. So for that reason, we have the different formulation for this inner liners. This is the bead. This is the bead. This is the bead means what? This is bead is made of steels. So, and it is actually anchoring the tire to the rim. This is called sidewall. It is actually give us the cushioning effects. So these are the broadly, if I say it's a tire construction, and it's a what I have discussed is a radial tire construction. It is the latest technology what I am discussing right now. If I go the basics, that is what is the radial versus bias tire. So if I see, that is the bias tires is the old technology, radial tire is the new technology. Bias tires, the ply orientation of the bias tires is having a different angle. It is a around 39 to 40 degree angle is there, but in case of radial it's a 90 degree. So this is the basic difference between the bias and the radial ply. But the radial tire having a better advantage, because the high speed capability and the steering capability of radial tires are much higher, and also it can save the fuel as well, because the rolling resistance of a radial tire is less than the bias tires, and the total life of a radial tire is much higher than the bias tires. So nowadays everybody is working on the radial tires only. We can see few bias technology in India as well, but it is now in a reducing phase. But radial tire is actually slowly it is actually in a increasing population is going on with this radial tires. So if I go with the types of tires, that based on applications, there are different type of tires are there. That is called passenger tires, truck bus tires, and the off the road tires. That is called OHT tires. And based on the usage, that is called highway tire, all-terrain tires, and the off-road tires. So the purpose of this slide is that as per my need, the tire patterns, tire attributes, tire designing input actually changing from application to application, and as well as the best usages as well. So if I go with some basic details of the tire designations, that is every tire is actually designating through the sizes, because because everybody having our vehicle. So if I go to and check what is the size is written onto the tires, that is very much interesting to you actually, because say in my car tire it can be 195 65 R16. It is a tire size, it is a designation of a tire size. 195 is called the tire width, and the 65 is the aspect ratio, that is the height versus width ratio, that is called aspect ratio. And R stands for the radial technology. So I am just telling the two technology, one is the bias, one is the radial. So whenever if you see in your tire, if it is marked as R, so it's a radial technology. And if there is suppose if you see in a truck, generally nowadays you can find there's a 10-20. So 10 is so this dash means the bias technology. So in that way you can recognize your tires, as well as whenever you see any tires, is there any dash in between the size name. That is, dash means there is the bias technology, is the old technology, and R means the radial technology. So this can give you some differences as a nomenclature of the tires. And the R15 or R16, so 16 is the rim diameter. So that way generally we are designated our tires. Second thing is that we mention into the tire there is the ply rating or load index, because every tire is actually designed based on the how much load it can take in. So if you see for the for the large vehicle, there is that tire size is different, and the load capacity, load capability also higher in from the smaller tires. Okay, so the ply rating and load rating is given to identify what how much load can these tires can check in. There is some pattern code. If you see, there are different type of pattern code is there. There is a manufacturer, they give some pattern name. Then there should be on manufacturer's name, whether it tires is made by X company or Y company. So company name was there. And another unique thing is that there is some serial number is given, that is called actually there is a unique number that every tire having their different unique serial number. That can be, it is because due to the back trace of the tire if any failure happening into the market. So this is the basic designation of a tire. So it can be written like that sidewall marking. If you see in your tire, that you can find. So and this is the some basic dimension while designing any tires, that is called tire sectional height, then tread width. So these are the some basic dimensions that whenever the designer actually designing the tires, so that dimension they have to follow. So again, the question is come that why the tire is special? Because this is the only part that vehicle that touches to the road. Because if you sit on a 10 lakhs car, or if you sit on a 20 lakhs car, the difference is only because only the tire actually. Because why? Because this is the part actually touches to the ground. Other functionality and all depends on the performance of the car. So whatever the black picture you are seeing, this is the actually tire footprint. This is called in our tire language, it is called the footprint, or it can say it's a contact patch. It is very it is very important, because it all the things are depends on this footprint only, because these footprints can tell you what is the area of the footprint. So bigger the area, better the traction, correct? And if you can say that tires having the what can be the braking distance, it will depends on this pattern design actually. How how the tire noise is generating it, also the answer is also again through this pattern only. When what is the weight grip of a tire? Suppose if you are running in a wet surfaces, suddenly you brakes, then the tire slip. Why it is slip? Because the traction at the wet surface is not enough. So this footprint is actually very much important for any tire engineers to finalize their tire designing. Okay, and then it is a highly non-linear, as I told, because it has rubber, cord, steel belts, and fabric layers. So everything have their different property. So if it is very difficult to combine all the on the difference of stiffness material in a one product, it's very much difficult. Then the load generally carry by the air pressure and the cord tension. So we are so whatever the pressure, because see, when we are going to the petrol pump, then we actually after checking the petrol, we go for the pressure checking. So generally what happened actually, whatever the persons actually who is actually putting the pressure, he actually decide what pressure actually we should keep into our tire. But if we can see, there is some mentioning, we are mentioning as a design point of view, we are mentioning what is the right pressure onto should be into the tire. So that is mentioning onto the tire. So if tomorrow if we can go to the petrol pump, then we can check our pressure, or we can put our pressure as per the as per the mention into that on the tire actually. And this is fourth point is that is a multifunctional performance in one component, because this component, these tires, we need everything at a time. One is the traction, one is the comfort, one is the stability, and one is the durability. So lot of functions, multi-functions we require from these tires, because these tires depends, because the performance of the tires depends the vehicle performance. So for that reason, tire is a very much important product for any tire, any car or any vehicles. So quickly, if I go through the what is the NPD process, this is called, we call, there is a new product development process. So what is that actually? So it's a voice of customer to the customer satisfaction. So it is the total cycles. So if we go, that is the whatever the requirement of any product that is come from the market, right? So the marketing team has working on the new product requirement. So whenever the new product requirement has come, so we got some input that yes, these tires will go in this market, these tires have to have take this load, these tires having this speed limit, and this type of terrain, this tire will actually walking. So this type of information we are taking from the taking from the marketing, and from there they are actually give us some benchmark tires, that this is the best benchmark tire that is actually working very well into the market. So accordingly we are deciding our benchmark tires. So then we procure the benchmark tires, and then we are and again we do the reverse engineering of this benchmark tire. So we prepare some design input analysis. So after designing, we are fixing some, the outer part of the we call as a cavity. So we start the engineering drawing of tire. So we make the product cavity, product layout, and we make some pattern presentations. We make some pattern. We make the sidewall, whatever the written onto the tires, how it will look like. So everything we are preparing, and again we are after that, after approval of everything, we go for the mold manufacturing. So we are going for the manufacturing of the drawing. So after manufacturing of drawing, what we are doing, so as you know, that tire is actually going through the compression molding. So for that we need molds. So for tires, we, after procuring the molds, we are making few tires. It is called as a prototype tire. So generally we are making 3 to 4 tires and checking whatever the product layout we are product layout. We mentioned that there is some cross sectional, maybe some dimensions, maybe some thickness, maybe some gauge, and we decided some indoor testing into our in-house. So whatever the indoor test we are decided that this tire should be passed. So we are making 3-4 tires, and these tires going through this type of checkpoints, this type of testing and all. So after after getting all the satisfied results, we if any modification is required, then we go for the trial run. So what is the trial run? Now the tire actually is okay as a geometrically, it is okay as a testing result also, indoor testing is also okay. Now we have to check what is the process capability, whether I can make these tires with my existing process without defect or not. So that is called the trial runs or pilot production. So we go for the pilot production, maybe few numbers like 30, 40, 50, 100, like that way. And after that, if everything is satisfactory, and if my process is capable, so we are studying the CPK, PPK value, and if it is okay, then we go for the regular run release. Correct. So this is the cycle actually, and this cycle takes around 1 year time. So if I say from voice of customer to customer satisfaction, it takes around one year time. So for my designing any tires, it needs 1 year to come to the market. So the things actually I elaborated into the same fashion. So I'm just skipping this. I already elaborated on all the things, so I just skip this slide. So these are the design steps that actually I already discussed, that what is the requirement. So main thing is that the requirement definition or input collection, it is coming from the marketing. Then second step is the architecture of cross section designing actually. So that architecture, so now the designer working on that is a sectional width, outer, whatever the dimensions, whatever the belt width, belt angle, everything to define a tire. So everything we are making the layouts and all in this phase. Then after that, it will come the material and compound selection, because as I show you, there are a lot of different components are there, and different components having their own compound formulation. So I have to select the material, you have to design the compound. Then after that, fourth, it is come, the main part is coming the simulation and analysis. So here, what we are doing there, we are actually checking what is the inflation growth, there is a footprint, there is a vertical and lateral stiffness. So everything, the capability of simulation we have, so we are doing the simulation analysis. Then this is the pattern engineering. Then I told it's a proto building. Then it is the validation testing, indoor testing. So we are doing some, because every products are going through some validation and testing. So everybody having their in-house capability for indoor testing. So everybody is going for the validation. Then we are go for the design freeze, then tooling release. Everything we have done the next phase, and then there is some homologation. Homologation means if I selling the tires in India market, so we need the BIS. So BIS having their own testing standards, or if I sell my tires as a Europe, so it is called EC marking. So there are several marking standards are there. We have to meet the standards and mark as a BIS IS standard onto the tire, or EC stamping onto the tire. So after homologation, we can do that. So as I told, this is the tire design. What are the tire design input? This is a vehicle type like passenger, truck, or OTR, then speed rating, regulatory performance targets. So everything I mentioned in my earlier slides. So these are the inputs. That is it should have the load carrying capability, then traction, it should have traction. Then it should have a lower rolling resistance, because rolling resistance is a upcoming topic to every tire manufacturers, because everybody asking for the lower rolling resistance tires, because also when the EV has came, so less rolling resistance tire is required by the current scenario. Then it should have durability, fatigue life. Then it is a wear resistance. It should have a wear resistance, because we need some projected mileage of these tires. Because another thing is that the heat generation and the dissipation, because when the tires actually running onto the roads, so every time when tires touches the ground, it actually it deforms. When it deforms, it actually produces the heat. So when suppose if on a stretch, if we running from the 300-400 kilometers, then what happened actually, so tire revolution will be very high, and then that time always there is a chances of heat generation and heat generate actually. And so I have to design my tires in a such a way that it should sustain the heat. Because previously what happened in case of bias technology, you cannot run the tires maybe some 60-70 kilometer stretch, we have to stop again, you have to cool the tire, and again you have to run the vehicle. Nowadays as the advancement of technology happened, so heat generation is not right now not a very much concern. But while we are designing any tire, so heat we have to have less heat generated compound we have to design to avoid any heat failures. It's a right. Next point is the right comfort. So when the designer is designing a tire, they have to check what is the vertical stiffness, because very much important vertical stiffness, because it's actually give you the ride and comfort. Then handling and stability, because how fast or how easy you can handling your vehicles with the tires. This is again a challenging job for any designer. Noise I already told, because nowadays the regulation tells that below 72 dB you have to keep your tire noise. Also, as you know that for the EV tires, the challenge is that EV doesn't have any IC engine, so there is no noise itself from the engine, and so only the noise is coming from the tires only. So nowadays very much challenge for a tire designer to design a tires with a very less noise producing. Safety regulatory compliance, we have to have some legal and safety standards, so we have to have maintained that standard. So these are the point that a designer actually taking while he is actually designing the tires. So these are the tire design parameters we have already discussed. Then suppose if I give some example that how a designer actually designing a tires, that is, you can say there is some benchmark tires. So as per the benchmark tires, there is some values that given by the marketing, or as a product requirement, it is the required dimension. So in our case, as a designer, what to do actually, in a designers, they always try to give some more extra into the new tires while he is designing. So he's trying to keep some more dimensions, more edge to the new tires. So that in that way we are fixing our designing the new product. Then this is one of the typical example how designer designing a lug or the pattern, how they are designing. So there are a lot of geometry they are comparing, and they are trying to put the best fit to the applications. So these are all the things that as a designer do while he is actually designing the tires. Then if I go coming, so it is interesting that this is this type of pattern proposal we are doing. Like this is my one of the existing pattern, this is my another existing pattern, this is my benchmark pattern, and how I can give some extra to the in for my organization. And also this is the proposal as a designer will make, and within that, whatever the choose by marketing, that is the final designing. So in that way we are first we are freezing the concept design. After concept design, we are making the 3D by CATIA software. And this is the tire that from this 3D view, they are actually selecting the tires, like marketing is selecting the tires for their business goal. This is what I told, this is the layout actually. So it is the half of the layout, while actually if you cut the tires, the tires is look like that actually. So I already told that tire is a torus like of thing. So this is actually torus shape. And if you see, there are a lot of components are there. So there are in this geometry, if I say, there are what may be my rubber gauges at different portions, or what may be my ply ending, what is the beat constant. So everything is given to the this cross section, this we call as a layout. And while we are actually while we are making the prototype, while we are making the trial run, these tires have to have, while we are with the actual tires versus this layout, should be matched exactly the same within the tolerance actually. So this is the basic engineering drawing for any tire engineer they are making, and as per this engineering drawing, the tire should be made. If I quickly go to the tire manufacturing process, that is actually follow in every company, there is the raw material selection. So first we are actually finalizing what is the raw material we are making the tires. Then the raw material we are going for the mixing. Then after mixing, we going for the component preparation. Then there is some bead making. Then this is the tire building, is the assembly area. If you see, this is the assembly area where all the components actually assembled in a green condition. Green condition means it's a uncured condition. So everything actually assembled on a drum. So this is called called as a tire building machine, a tire building. And then is the curing. Curing is the process where actually tire is vulcanized, and it is happened due to it is in a compression molding, and having with the help of temperature and the pressures. After that, it is go for the inspection, and after that the tires are going for the, after quality check and all, that tire is going for the dispatch. So now the question is that why tire design is very much critical, because as I told you that the tire designing is the process where we are making the tires with a mold. So the mold cost around in a tire, in every industry, if you see, we are generally ordering the two molds for any new product. So what happened actually, the mold cost is generally, if you say, it depends on the sizes. But if I take as a medium size, that mold cost is around 10 lakhs. So 10 lakhs into 2, so it's a 20 lakhs cost is a two mold cost actually. So it is a very big cost for a tire company. And every year, suppose if I have to make 200 molds in a year, so the cost is very huge actually. For going to the mold manufacturing process, so the design should be robust enough that can because after that the tire can meets my expectations. So previously what happened actually, if I go with that that previously what happened actually, as I told, the designer actually depends on whatever he has previous design experience, whatever he have some, a similar kind of designing with him, or other thing, that is the judgment. Okay, so how any designer, how he can judge, that depends on the design quality or product quality. It actually after that it goes to the product quality as well. So now, there was a very much gap when actually the previous designing process. Now every tire industry in India actually now going for the finite element analysis process. Because, so say, if you say in terms of time, in terms of time also, the generally the tire designing is around 90 days time is required to designing on tires. There is a process of mold manufacturing. The duration of the mold manufacturing is 120 days, and there are some product verification and validation part is there. So total, if you say, and total if you say, it needs a 365 days. So if my design is not correct, so I lose 365 days, that is the 1 year, and with the cost of say 20 lakhs and all. So there is always a very much risk while I am designing with my orthodox method as old school thought. Now everybody actually working on simulation, so make the designing more robust. And so there is no such mistakes will happen, that can reduces my designing time as well as the cost. So 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 the finite element actually take places very much, a very much important role in case of tire industry. So this was actually the gap what we found in tire industry, and everybody actually now, going through this finite element analysis process. So because FEA, predict the performance very early, because before the mold ordering I can say this tires having that will be this much dimension will come from these tires, or the performance we can check the footprints and all that will come at later stage. But so we can predict my performance early. I can optimize my design. I can do DOEs as per my requirement. I can change the angles. I can check. I can increase the diameters. I can increase the Lancy ratio. So that there is a very flexibility is there in case of FEA. So, and it is a reduce the development time and understand internal stresses and strain. So these are the advantages we can found in the FEA analysis. Again, if now the question is that, so if I go for the FEA, then again FEA, why it is actually FEA is challenging for the tires. First thing is that tire is a very non-linear structure. As I told, why it is non-linear, because there are three non-linearities there. One is the material non-linearity, because tires doesn't follow the Hooke's law actually. Means the rubber doesn't follow the Hooke's law, because the stress and strain is actually non-linear. And for the rubber is a very large strains. If I give some force, then the strains are very very high. And so you can say it's a hyperelastic behavior is there. Also rubber having the viscoelastic behavior. And also the different, as I told, that the steel having their different elastic modulus, and then the plies, that is the nylon and the polyester having their own, and the rubber has their own. So as it is a very composite material, so it is, with to make as a combine, it is very difficult to do the FE analysis. Then there is some geometrical non-linearity. What is that? There is the, suppose when actually tire touches to the ground, there is some bending happening. Sidewall, there is some bending happening. When tire touches the ground, the footprint is flattering, because my tire was round. Now it touches to the ground. Now my footprint is now flatter. So again, it is a change of shape. While my and another thing is that the belt tension is distribution, because when it is touches to the ground, the belt again it got tension and the angle change. So everywhere there is a geometrical non-linearity is there when tire is moving. And there is some contact nonlinearity also there, because road contact is changing continuously, the contact area evolves. Suppose when the tires actually touching to the ground, it changes the shape, and when it is actually coming out from the road, then again change the shape. So there is contact nonlinearity also there in case of tires. So for that reason, it is a very difficult to do the FEA simulation for a tires. Another thing is that this is a very conflicting performance target. Suppose if it is called this triangle, if you see, it is called the magic triangle, because everybody wants the tire rolling resistance should be low, weight it will be the better weight grip, and the wear resistance should be high. But if you see in the tire property, everything means all the things, if you cannot, if you suppose when we actually lowering the rolling resistance, what will happen actually, then grip is very much adverse effect on the grip. So always there is a balance should be there in while we actually designing the tires. So what is the requirement of the tires, that actually very important for a designer. But fact is that there is a multiple conflicting performance target. So the performance target is very much difficult to achieve these targets. Another thing is that while designing any tires, actually there is no method in physically, there is no method to check what is actually what happening into the internal of the tires, internally into the tire. Suppose when that tire touches my ground, uh, so now what will happen actually, the belt actually, if you see, this is called belt. The belt edge actually, there is some strain and stresses are coming to the belt. Suppose when the tire touches to the ground, the footprint, there is some stress distribution, different stress distribution happening onto the footprint. There are some open edges that is called as a turn up. Turn up means the why the ply actually end, that is called as our language is called turn up. So then this is a free end. Again, whenever if you see it's a moving object, so when it is touches, then turn up. So whenever the turn up actually what happened, the different as it is a moving object, so there is some stress concentration happening to the turn up. We are actually fixing the tire with the rim, so there is always an interference between the rim and the tire. So previously it is not possible to understand what happening into the inside of the tires. So now, so it is these types of, so the validate the FEA, because see, if I do go for the FEA, I have to validate, because FEA is a theoretical result, and then I have to validate to some practical result. But problem is with the tires is that this type of stress, I cannot measure any stress, though no instruments having we have that I can measure what is the beltage strainer at the beltage area, or what is the turn up strain energy is there, or what is the foot. So these all things actually not possible to validate. So these are all the challenges while actually going for the FEA. Sometimes what happen actually, design decision are irreversible early. So it is, the point is like that. Suppose if I go without FEA, then what will happen actually, that my mold design or my pattern design may not appropriate as per my requirement. So earlier case, what happened actually, the design was, there is a chance of irreversibility of the design decision there. So, and these are the some example that how actually we are where going for the tire development. These are the some machines examples I am given, that I can correlate or validate my FA result with the testing result. So this is all are the indoor testing machines. This is a pulley wheel machine. If you see, this is a pulley wheel machine, and tire is runs at per the load and the speed whatever we require. With this machine we can give some sleep, we can give some camber. So whatever my requirement I can give into the, so it is a validation machines that can give me the confidence before going to the market, that can give me the confidence that yes, my design is correct, my design is appropriate. So these are all the machines. And this is the footprint machine. This is called the footprint machines. With these machines we can check what is the stresses has came onto the tire footprint area. So these machines having a both type of advantage. One is that this is the give you confidence that yes, my product is will perform well, and other things that this machine can help you to correlate whatever the FE output we are having, that we can correlation we can do with this type of machines. So this is the thing that now I am coming why the FEA introduced into the design stage, because physical tests control reveal internal mechanics. Design decisions are made before prototypes. Multiple design options must be evaluated. Risks must be reduced before the testing. So these are the important thing, because as I told that previously, we don't have the chance in between mold design and to the release of the product. We don't have the so much tools to check whether my design is correct or not. So FEA give us this facility that yes, I cannot tell that yes, this design will perform or not. That idea, that results are nowadays coming from the FEAs. So suppose previously there is no FEA, so it was a slow, costly, and time-consuming process. And then now if I introduce, that is the designing, that is the modern and the fast and the cost effective, because there is no cost involvement for the testing of because see, I can do n numbers of DOE with the FEA simulation, so there is no such cost cost involved to take to do the different variations or different DOE of the tires. So what is FEA? FEA is everybody knows that is a computer-based simulation method. So what is the outcome actually? Outcome is stresses, then strain, then deformation, then temperature, and the fatigue risk. So these are all everywhere. You can see these are the things I can check in through the FEA. To stress, strain, deformation, temperature, and fatigue risk we can check. So with tire, now I give you some example that how we are actually checking our different outputs from the FEA. So again, there is one of the example like this is the some analytical solution. It is a cantilever beam. So we are calculating with different equations and all. Then now FEA can give you the results actually. So these are all the steps, basic steps we have written here. So like suppose in case of tire FEA workflow, if we say, so we are giving this type of geometry that is called the tire product layout, what I have discussed already. So this is actually the basic geometry of a tires. It is called the cross section of the tires, and we called as a layout. So we are giving this type of layout. Then we are going for the material modeling, means what are the material we are using. Say rubber, what type of property. Then it is the belt. So what type of property should I assign? Then there is sidewall, different property. Then again bead, there is a steel, again different property. There is a ply, it may be nylon and it may be polyester, so different property. So I have to assign the property. Then this 2D model, we are meshing this 2D model. Then after meshing, means it breaks into the some small element. Then we have to put some boundary conditions, right? So what is the boundary condition? That we are putting that rim is a rigid, okay. Then this type of boundary conditions we have to apply to the FEA. Then there is a load application. How much load I will apply, that I have to that I have to give to that to the FEA simulations. And after that, so it is a solution and the post processing. So like that, so it's a tire design layout, then meshing, then chord formulation, then this is the 3D pattern. So again, we are meshing the 3D pattern as well. Then with the 3D pattern and the asymmetric model, that we can revolve it and give the pattern. So it is a whole tire now, my tire is ready for the simulations. So I have to apply the boundary condition, load applied, then the material definition I have to put, and then FEA now can perform the virtual performance. Now I can check from these models as well. So I already discussed this tire material, that rubber is a viscoelastic behavior cord. So I'm not going to this. I'm skipping this. So see, rubber is a two important feature or properties that there is the rubber is a hyperelastic material modeling, hyperelastic material, and there are a lot of material models are available in Abaqus that generally we are actually using Muni Revlin or Neo Hookean or EOS model we are using for our Tyre FEA models. And this is the uniaxial testing machine, and with these dumbbells there are some rubber samples are there, so we are actually check what is the stress and the strain value. So there is some so we are actually what we are doing, we have some testing method and we are plotting the curve of stress versus strain. And so with this model, with this hyperelastic model allows to FEA that this can give is the footprint shape. So with this elastic hyperelastic material property, the tires can give us the result of footprint shape, then the contract pressure distribution, vertical stiffness, then sidewall deflection, and then the dimensions of the tire. What is the inflated? Because for a tire I have to put some put inflation pressures. So with this inflation pressure, what may be my dimensions, whether the dimensions are within the standard or not. So that type of FEA simulation can be done through hyperelastic material modeling of the of in Abaqus FEA. Second thing is that sorry, it is mistake. It should be viscoelastic material modeling. This is called the viscoelastic materials material modeling. It is the machine from where actually is called the DMA. And with this DMA, what we are doing, we can with this property, we can actually we are placing the temperature sweep with the long with the stress, and the Maxwell model actually working in is a very good result in this. And this viscoelastic model, FEA model, we can predict the rolling resistance. That means the hysteresis loss we can predict. Then heat buildup, what means, how actually it is behaving, or how much in a heat is actually generating while it is running. So that type of heat buildup property that can give. Then there is a dynamic stiffness, which is in a rolling conditions the stiffness will be different, though. So that dynamic stiffness we can measure. Then the ride and NVH responses, that the noise and vibration if so everything we can predict from this viscoelastic model. And the durability and the crack growth zone. Suppose generally what happens actually in the model, if I create a cracks, and how these cracks actually behaving while running the tires in FEA simulation, that can be predicted through this viscoelastic model in FEA. So now I am giving some examples that how actually common tire simulations actually we are applying in our designing tires. So first, that is we called as I told, this is a mold. That is called is a mold of the tire. The black one is the mold, and this green one is the inflated dimension. So as I told that every tire is having their own having the specified inflation pressure, that we have to give some pressure into the tires, actually carries the load. So after inflation, how much my tire inflated, what is my inflated dimensions, that I can predict from this simulations. Prior to that, there is designer having their own experience, or they have some previous experience data that yes, this tires have a growth of say 2% from the mold and all. So nowadays this type of, if my material model and the tire models are perfectly okay, then I can predict what is my inflated dimensions will come, that I can predict. And so then now the designer are getting more confidence to releasing the products in terms of dimensions. Now the animation shows that how actually rim is fitted into the tires. And if you see previously, there is no way to actually check what is the what is the stress value at the rim contact, because as you know that rim is actually anchoring to the tire. So there should have some interference between the rim and the tires. So whatever so this is called actually bead area. So this should be this should have a stress value should be higher, because it has to has because if this value is less, then this value that the rims will be slip onto the rim. So nowadays what happened actually, so from this type of simulation, I can check, I can oversure that yes, now whatever the stress value is there, it is okay for me to release my design. So and another thing is that there's a flange area. That flange area actually, if you see the rim, it is called the flange. And the tires actually, while it is in a loaded condition, then tire actually deflects and it takes the support of the flange. So now the question is that how much flange how much pressure or how much stress I can allow actually. So in that way, FEA give us some values actually, that this may be 2.3 megapascal and all. So suppose this is the ledge, the value is 4.08 megapascal. So we are checking this stress value with our inflation pressure actually. So there is a correlation between that, how much inflation pressure, how much ledge megapascal stress is required. So we have actually correlation on that. So accordingly, we can finalize if it is a less stress and also we can understood easily that there will be some slip, or it may be there is some stress is much higher, so there is some possibility to damage the tire as well. So in that way we can predict, we can take a call that yes, my design is perfectly okay or not. So with this simulation I can predict in that way. Now it is a it is we call it is a the simulation method we are applying for the, this is a agriculture tire. We are developed this method, that how I can predict my contact patch footprint, I can contact patch, how I can predict. So this is the process actually. And as I told, that footprint is the key success of any tires actually. So if any designer can meet the footprint of in a very good benchmark, then you can say your design also can perform very well into the market. So in that way, we can predict, we can check what is the footprint length, what is the pressure. And one interesting thing is that there is always a challenge of a designer, is that the stress should be uniformly distributed. Because if you see that the green portion actually that touches to the ground, touches to that surface, and my now I can say that my stresses are uniformly distributed. Suppose if there is a variation of the stress, say in the middle of the tire, there is some high, the red zone is there, so I can easily predict that my designing is not correct, I have to change some angles, I have to change some radius and all. So with this simulation, FEA can give us in a good indication that whether your stress is uniformly distributed, or whether, say, this is a footprint length. Suppose, as you know, the agriculture tires will 30%, 40% tire actually applying into the field. Okay, so in field, what is important, the field what is important, that is called the contact patch. Then contact patch is defined on the footprint length. So more the footprint length, that torque, that it can generate the torque. And if you see, the more the footprint length, the soil compaction will be lesser. So in that way, as a designer, we can predict for however the applications, on whatever the applications, how I can moderate, or I can balance my footprint as per the application. So this type of indication that we are taking from the FEA as an input, we are taking as a input. One example I'm giving, this is a simulation versus testing, because this is, if you see, this is the simulation result, and this is the we measured in our testing. We have some machines that can give us some result, that what is the different stress level, like that. So we can correlate, we can, if you see that the correlation is very good actually, because say generally we have found that there is a 95% correlation between the simulation and the testing. So now if you see that, now in a day by day, with the help of this correlation, now day by day you can see that the FEA is a, in a very powerful tool to decide the designing actually. So if you say that the stresses values are more or less same, there is a zero point 0.7 and the unit is different, but the scale, if you see the stress distribution, you can see there is a lot of similarities are there in actual versus the simulation result. So we can say that is a very good correlation. So as experience of it is actually depends on the experience of the simulation engineer, how actually they are giving inputting the raw material data to the simulation, and how the model is perfect, so it all gives the better or accurate result in the results. Another thing is that we told that prior to that we don't have any chance to check what is actually happening inside of the tires. From this you can see they say this is the end of my belt. So now, as I told, it's a free end, like belt, like my turn up area is all are free end. So generally the strain actually happening, because when it is a loading to unloading, there is a frequency curve actually. So every second, within a few seconds, tire is coming to again the contact patch. So there is a the frequency of touching to the ground is very high for the tires, and when it is speed is goes up, these frequencies are again more high. So these type of things actually not able to predict earlier. Now with the help of FEA, I can predict, I can check. Suppose there is some, if I say we can compare from design 1 to design 2, that what is the actually strain level is coming into the carcass end, or into the, so whatever the failure that is due to the inside behavior or parameter changes into the tire, that we can easily predict through the these FEA solutions. Another thing is that the heat buildup. Suppose, as I told, that there is always the tires when hitting to the ground, so there is a cycle. So heat is actually generated. Now suppose if I use compound A and compound B, so I can compare with both compound A and compound B, what is the heat zone area actually. So that type of comparison I can do. So if whatever the happening into the inside of the tire, so that can be easily predicted through the common simulation process. Again, one thing is that this is the we call as a suppose when we are taking the 30-degree slip angle actually. Suppose this is the it is a straight line rolling, if you say. Now what happened actually, sometimes while we are going for the cornering of a tire, what happens sometimes, that tire can perform in a straight road, it is very good. But while we are taking some cornering and all, so then what happened actually, the we suddenly loses the grip. And because grips are very important while actually we are driving a car in a 1,000 kilometer per hour speed, because at that moment if I lose my grip, then the vehicle can overturning, and we can got an fatal accident on that. So so in this FE simulation and all, we can predict that how it's happening if I go for the higher angle of steering and all. So everything that whatever our application practice, that we can generate here in the FE simulations, and we can judge whether this area or this contact, whether it is perfectly okay or not. So that we can discuss, that we can predict, and we can go for the best design for this type of application as well. So these are the some examples of FE simulations that is going on happening, that is actually we are creating our own, and try to implement in our designing stage. Another interesting example I am giving, because this is example of the stiffness. There is a, because say this is my tire, and tire braking distance depends on depend on the tangential stiffness of the tires. Now prior to design, it is not possible to calculate, or nothing able to calculate that what may be my tangential stiffness, or when tires is actually going to any bank or something like that, there is some lateral stiffness is happening. So I cannot predict, really we cannot predict, but with the FEA we can predict what is the tangential stiffness, because tangential stiffness is such a parameter that actually give you the braking distance or acceleration, how fast I can accelerate. That parameter will coming from the tangential stiffness. Lateral stiffness is a component of a tire that actually, suppose while you are in a straight line curve, what happened actually, there is always a chance of lateral shipment of the car. Suppose so what we are doing actually to keep in a car in a straight line, then we are actually then again correcting our steering. So this type of problem I can calculate, or I can predict from the lateral stiffness of the tire. So what is the effect of the pattern designing while actually creating the lateral stiffness, that can easily give from the simulations. Another interesting, I can say, it's called, we are trying to develop in the agriculture tires. So say agriculture tire actually generally using into the field, correct? So now what happened, because see, it is very easy to predict a road surface as a rigid, but problem with the agriculture tire is that the soil, because the soil, the nowadays it is very difficult to characterization of the soils, because we are working with some with IITs and all for the characterization of the soils, because it is very difficult to characterize. Because, and if we can develop this soil soil simulations, then it will be very easy to us to predict what is the soil compaction. What is the soil compaction means, when actually tires actually hit to the field or soil. There are different type of soil, as I know. There is a hard, soft, and the medium soils are there. So suppose it is a medium soil or soft soil, then what happened actually, the lug actually, if I say this is a pattern, it is called lug. So lug actually penetrates, or it actually goes into the soil bed. Now what happened actually, then soil actually, this actually we call, say, the soil actually very tight in that place, we call as a soil cone index. So soil cone index should be like that, the germination of the crop should happen actually. So this type of, from this type of simulation, if I compare with design 1 to design 2, so I can predict that how much compaction is creating to the having to the soils, and what is the best I can give to the tire, so that the soil compaction is very low for the good soil germination and all. So this type of study we are now actually doing in our FEA simulations, uh, and try to check what type of pattern, what type of design change can give us the better result for a rear tractor, for a tractor tire into the field. So this is one of the tests we are actually doing into the IIT Kharagpur. So here they have the setup is there. So that if you see that the when that while the tire is passing through a soil bed, what happened actually into the soil bed actually. So they are measuring the depth of the lug actually. So it will be always better, the depth of the lug or the depth of the penetration of the lug into the soil as less as possible for the good any good tires actually. So these are all the things, that is the so this type of we are now try to correlate with this result with our FEA simulation. So we are studying on that. So if we can if so it is maybe half of the way we are actually we are in the solution phase. But if we can do this type of soil characterization, and we can do the FEA simulation, so that can actually reduces the cost of this type of testing. And we can easily we can predict what is the performance of the base tires into the soil applications. So, and another point is that it is also a more important thing, that how I can predict the rolling resistance of the tire, because rolling resistance is it is not due to only the friction. Actually, rolling resistance happen actually due to the mainly reason is the viscoelastic behavior of the rubber actually. Because when if we can if I load if I go for any testing, that rubber doesn't follow the same path, correct, when it is in a load and when it is in an unload. So then there is always the rubber always taking a different path. So this is the loss actually. This is called, we call as a hysteresis loss. And this loss, due to this loss actually means energy given to the vehicle, energy given to the tire is not actually coming back to same amount. So for that reason the losses are there, and these losses actually cause the rolling resistance. So this simulation, this type of simulation, every company is try to develop right now in tire companies. And the challenge is that because the correlation between the real rolling resistance and with the simulation is there is some gap. So people are working on that. But yes, in future, I think we should achieve this type of capability of FEA simulation in rolling resistance as well, so that so easily designer can predict what is the rolling resistance coming into the tires and all. So it will be great help to while design a right tires actually. Nowadays, as I told again, that EV is a very much coming to with a this type of requirement with very low rolling resistance tires. And every time it is not possible so you do the design and then again test. So they, in that way, if you can give us help us in to predict what is the rolling resistance coming into the tires, it will be very beneficial for the tire industry. Another thing is the interesting.
Sir, sorry to interrupt you, but the time is almost up.
Okay.
So it will be better
Okay.
if you wrap up your session.
So just I'm going with some a little bit. There is a tire noise and vibration. If you see the, as I told, that the tire actually it is a moving part, and there is a the noise actually generating. So for that, designer are doing with a different geometric. And also if you say that, if you see in your tire as well, that we will find there is a different pitch. We call it as a pitch, means every block I can say is a pitch. So that way we can predict the noise level, we can reduce the noise level. So designer are doing in that way. And also FEA simulations, with the help of FEA simulations, the sequencing of the pitch is very important for noise generation. So that actually we can we can predict from the simulation as well. This is on type of vibration nodal analysis for the tire as well. So these are all very advanced simulation that we are doing here. But this is very critical, but it is very tough also, because this type of simulation is very difficult to perform, because it needs a lot of computation time and hardware as well. So again, the what is the limitation of FEA? Limitation of FEA is that we should have to put the accurate material data. Without accurate material data, the result will be different. There is some computational cost is there, simplification is required, and the experience dependent result. Because FEA, whatever the who are expert in the FEA for the more longer time, they have their own experience to make the result in a very easy method. So this is all the key takeaways from there, that the tires are very complex and in engineering systems, and FEA is a very much essential for the modern tire designing. And simulation and testing, that can give the successful product. And some strong fundamental matter more than the software is required to design a tire. So this is my conclusion, is that So for us, the tire designing and tire finite element analysis are the complementary tools, because without simulation, designing doesn't have any value. And so if I can do correct design, correct simulation, and some physical testing, then the performance of the tire can be better and that way. So thank you very much for allow me some more times.
Thank you,
So
sir.
hope I
Thank you so
can,
much.
yeah. So if any queries is that, I can happy to explain, or if I'm not able to
So,
explain, then I can again come back to you also.
hello. I
Hello.
want to ask something. It was a very wonderful presentation. Lot of practical insights on this tire, which is
Thank
very
you.
much essential, and a lot of insight we have got. And I think that this the tires, whoever it is not only meant for engineers, it should be for all, because it's a very generic. Everybody is having vehicles, etc., and some information is very much necessary. Some
Correct.
basic questions I want to, some doubts I have. Actually, when you mentioned you have doing this crack propagation on the tire, because
Uh-huh.
tires are having
Mm-hmm.
crack. So, what
Yes.
is the constitutive model which you are using, and how are you doing it in Abaqus? Because that model is basically empirical and experimentally determined. It is not like Paris's law for metals, which you are having clear-cut
Correct, sir. Correct,
formulas.
sir.
So in this
Mm-hmm.
case,
Yeah.
how are you doing that analysis?
Sir, yeah. So for that, sir, actually, what happened, as we know that it is because for every model, actually, the elements are there. We are meshing the elements, and for the crack propagation and all, it is very difficult. It is in a, it is in our, it is in our means it is in a exercise phase only. Actually, we also means try to get some good result, because see, the element, it cannot breaks actually for any simulation. It cannot break. So it is very difficult to do. Actually, we are working on that, and we are using a few models actually. So that I can tell you, if you take my email ID, so I can give you some more details or more data. I'll be happy to share with you actually what models and all we are using. But yes, it is very difficult to because the crack propagation, anyhow, it cannot be, it is very difficult actually to do actually. So we are working on that actually. Because the generic whatever I shown you, actually, that is the footprint and all, we are doing perfectly well. But the whatever the advanced simulation that I told, that is the soil bed application and all, it is actually our learning phase as well, because we are also learning. We are also collaborating with some institution and all. So it is our learning phase only.
Oh, okay. Another question is regarding the life of the tire. Means,
Hmm.
do you have any data regarding, or do you have any simulation experiments? For
No,
example,
no,
like
sir.
your
This is
fatigue
this
curve.
is
Yeah.
also a very advanced simulation is required, because wear rate, because we don't have in model, in which model we have to do. We also searching on that. We are working on that actually. So it is very advanced level, because our company is asking us, how you can predict the life of a tires. Okay. So because see, it also depends on the what is the road structure actually, because every road having their own actually structure. So in any India, there is no data actually published that what is the road surface, what is the road
Yes, I agree, but that is very important, because from
yeah,
practical point of view, when you go for
yeah.
tire, they say after 2 years you have to change the tire, 5 years you have to change the tire. But since we are not getting an input from the manufacturers, so we just cannot actually do not have any basis to counter the decision, etc. Because sellers will always be trying to sell more tires so frequently.
Yeah.
So that is one point one is there, and another thing is that you had a pattern. So how do you actually design the pattern? So how do you optimize that? Because that's a very what you say non-standard and very weird looking artistic shape, or I do not know. How do you actually arrive at that shape?
Sir, actually, what happened actually for the pattern actually, because see, different because there are, as per the application, different tires having their different applications. Okay, like if I go for the tractor tires, so what we need actually, suppose nowadays if I give an example for the tractor tires, actually it is running 70 or 60% on the road and 30-40% on the field. So now I have to match both the things. So what we are actually doing, so I need for tractor tires, if I give you some example on that, because I have that example, for that reason I'm showing you. Suppose this is a tractor tires. So this is, it is called the lug actually, correct? So this is the called lug. So there are different geometries are there, sir. Suppose if you can follow that, these are some angles are there, right? There is a A3, A2, A1. These are some angles. So these angles actually define that how I can get the tractions. So suppose from any design point of view, I can change and I can check what is the traction actually. And this and we know that tire actually generally touches to the center line. So what we actually doing, we try to give more mass to the center line. So what happened actually, we are actually dividing these tires as a different zone actually. So see, it's a examples are few examples. Suppose it is my competitors, this is my existing tire, this is my new tires. So how I am keeping, I try to give more masses to the masses to the zone 1. This is the zone 2, because this is touches more. So for that reason we are trying to give more masses to the tires. And now the second question is the what is the performance. Suppose now I am giving the masses. Now whenever we give more masses, so that will give the more mileages, more life, correct? But how I can predict that my tire will be give the best performance into the field? For that reason, this simulation is very much helpful actually. So we are trying to do that actually. This type of this simulation. Yeah, this simulation is very much actually beneficial to us actually in a field or in a field type of situation. What is the actually the contact patch I get in soil medium? So that actually give you some more insight. Now how much mud, how much soil that actually, because for the traction then we have to have lock the soil, otherwise it will slip. So how much I can lock, so how my design can lock the soil, that is very much important as that. So for, because designer cannot tell that how, so but simulation can give us some best insight on this, that in design 1 or design 2, which one which will give you more traction on that. So that way actually we are finalizing. And different tires having, there's a different actually requirement. Like suppose if it is a PCR tire, so PCR tire actually working on for the the traction. One is the traction, one is the rolling resistance. Then so these are few from tire to tire actually the requirement is different, and the to way to see the tire patterns is actually different. So in a short, yes, it's a judgment. You can say it's a judgment. We are actually sometimes we are following the best tire makers in the world, whatever they are making. Sometimes we try to take some concept from this, and with the help of FEA, we can say yes, this my can, so I can give some more attributes to my product or not. So that way we are actually judging. So for that tire designing experience creates a create a lot of influence, because in designer who have the 10 years experience, who have the previous experience in his mind actually. So that way the design of the tires actually happening, sir.
Yes, thank you for your nice explanation. Now it is quite clear.
Sir, good evening, sir.
Good evening.
As an advanced situations, I come to hear that, and there are some YouTube orientation in such a way that the tires are being manufactured based upon the suspension system oriented than using the rubber and some other materials, sir. Is it fact,
Correct.
or just it's a creativity of AI through the YouTube, sir?
No, it is correct actually. What happened actually, today's world, if you see, if I follow the car segment, so everybody actually coming with the higher, means higher rim sizes. Suppose
Sir.
Creta, previously it was in 15 inch, now it is going 16, 17, 18 inch as well. So what
Okay.
actually they are doing actually, they are increasing the rim diameters, correct? Now when
Sir.
they are actually, hello?
Yes, sir. Yes, sir. I can hear you, sir.
Okay, so now suppose it's at my tire. So now day by day, what they're doing, they are actually increasing these diameters. While they are increasing this diameter, so what is happening actually, this, because tire diameter should be same, correct? Now I am increasing this diameter, so this height actually we call as a aspect ratio, this is actually reduced. So if you follow correctly, that tires maybe with 70 aspect ratio, nowadays it is coming with a 55-60 aspect ratio tires. So while actually, and this part actually, I'm just pointer is pointer. So this part actually giving the cushion and the suspension. Whatever telling, there is this give you the spring effect actually. Okay. So whenever it is
Sir.
it's a taller, then it gives you the good cushioning effect. When it is actually less, then it is give the lesser cushioning effect actually. So nowadays, that the tires with the vehicle manufacturers are actually asking from the tire industry that you give me that what is your spring rate, or we can call it as a radial stiffness. So you give me your dynamic radial stiffness to us, so that accordingly I will designing my spring, because after all we need the comfort. So how, because they are actually increasing the diameter now. While the diameter is actually increasing, what happened actually in the tire, so actually the sectional width, we call this width will actually increase. While it is increased, then it will actually give the more tractions. So whenever the vehicles are coming with a higher speed, then the steering maneuverability will be the better actually for that. So where the higher the sectional width, then the maneuverability will increase. So that way it is advantageous. But problem is that while we are actually increasing the diameters, then what happened actually, the spring rate or the spring constant is actually dying, lowering down actually. So to adjust this, now the suspension, they are correcting their suspension, or as per the tires.
Oh, sir.
So this is the fact actually happening for the tire industry. So for that reason, the simulation capability or the in-house test capability should be there to satisfy the OEM requirement. Otherwise, nobody will take tires from the tire manufacturer. So this type of things are happening.
Not only the suspension, sir. In fact, they are planning to make this wheel to be as a suspensional oriented, where wheel itself acts as a suspension. When it
Yeah.
have a up and downs, or when it have a rock oriented environment, or else if you have any differences in the roadway, or else in a little bit mountain regions, even there is a possibility for the wheel itself to have a shape according to the concerned object which it is going to face it out. Is it fact, sir? Or is the rubber cons? I mean, you previously talked about the rim, but I am talking
Mm-hmm.
about the structure of the total wheel is design, planning to design in such a way the material will be like a suspension. The wheel itself will be like a suspension.
No,
Is it
then it
fact,
is
sir?
not. No, it is not a fact actually, because see, because
Sir.
the wheel actually made of, if you can say, it's alloys and also the
Yes.
deformation should not allow the deformation actually, because how
Oh,
actually it will bend and at all. So it is not possible, or that type of flexible metal is not produced right now. So
oh,
the
sir.
rim is a rigid only. So we are thinking rim is a rigid, tire is a flexible element, and
Sir.
accordingly the suspension. So total suspension is actually addition of tire as well as the suspension system they have actually. But yes,
Okay.
tire rim is rigid, but tire is a, you can say, it's a spring.
Okay, sir. Okay, sir. So it may be artificial
Yeah,
intelligence
maybe
oriented
it's
and
a,
machine
yeah,
learning.
yeah.
Okay, sir.
Because
Right, right, sir.
see,
Thank you.
and if you go into more advanced, that you can search in Google,
Sir.
some Michelin tires having their own tire with, there is, it's actually airless tires. Okay, it is called twill. It is called, you can search in the web, there is called is a twill. That is actually there is and the rim actually made of, there is a hexagon structure like that, and it is actually different polymers are used to make these wheels, and tire is airless, only the pattern is there. So it's a different thing actually, it is not conventional thing. But yes, as you told that there is something going on with Michelin. If you follow the Michelin, then you can get some insight on that.
Okay, sir. Okay, sir. This is Satyapan sir from Andhra, sir. So I would like to know the
Okay.
information whether it is really manufacturing or else just a creativity of a human through AI. So that to have a
Maybe.
clarity, sir.
Yeah.
Right, sir. Right, sir. Thank you, sir. Thank you, sir.
Thank you. Thank you.
Sir,
Thank you,
good
sir.
evening, sir.
Good
Good evening,
evening.
sir.
Good evening.
I have two questions, sir.
Mm-hmm.
Is there any dynamic simulation done in your part, sir?
Pardon?
Dynamic tire simulation. Have you done anything related to that?
The dynamic simulation that I have showed that some give some example. These are all the dynamic simulation. Like this.
This is for the pattern, sir.
Yeah, pattern. This is
For
pattern. No, this is
the heat produced for the
yeah. Actually, see, our team is working on that because see now if you say the dynamic part is implicit is as an implicit part of the simulation, and it
Bhaskar.
will be
Hello,
typical.
Bhaskar. Hello, I'm
Hello.
audible.
Uh-huh.
Those participants are interested to know anything, and they may send email to you.
Yeah, they may
Uh,
send me through my email ID. If I can give some more insight, I'll be happy to share with that actually. So this is my mail
Yes, sir.
ID. So
Actually,
Actually,
today we have to wrap up our session. So
okay.
I would like to request the participants who have any questions, please note down the mail ID and contact sir through the mail.
Thank you, sir.
So thank you for the insightful session.
Thank you.
So I hereby announce the conclusion of the third day's session. We sincerely thank you, the esteemed dignitaries, speakers, and participants for their active participation and cooperation. With this, the organization team is signing off for the day, and we look forward to welcome you back tomorrow at 6 p.m., sir. Thank you.